Hi. I came here from Europe for this event, and I'm really happy to be invited to speak to you today. And I think maybe the subtitle for this talk should probably be, in brackets, that you need to manage. Okay, so applications without infrastructure that you need to manage is probably the right title. And there's always a cheap joke here, which anybody talking about serverless will use, which is to kind of, comedically reveal the fact that there are actually computer systems involved in delivering serverless apps. It's been used so many times it doesn't even get a laugh anymore. It's great. So you can find me here on Twitter if you have feedback, questions, disagree with what I say. I'm very happy to take feedback on this talk. And actually, when we announced AWS Lambda coming up to 2 years ago now, we were continuing actually with some of the core characteristics that AWS was built on from day one. So if you think about the way in which, and Adrian trailed a little bit of this in his earlier talk, if you think about the characteristics of this new architectural model where resources are accessed, even created on demand, it really is an extension of what we started with when we started thinking about changing the model for delivery of infrastructure back in 2006 when we launched our first services like S3 and EC2. And today, these characteristics are really, really well understood, actually. So, on-demand resources, the ability to pay only for what you consume, and this shift away from having to do everything yourself, so building and operating your infrastructure, towards a model where you're consuming expertise from other parties. Some of it might come from AWS, but also a lot of that expertise, those capabilities come from APIs that are provided by other organizations. I think we'll talk at the end of this session about the way in which AWS Lambda can act as a broker, as an access mechanism for using other people's software capabilities inside applications as well. So I'll come to that at the end of this session. I'm going to skip this because we've not got a lot of time today. So broad adoption of AWS. And when we started this journey to create this new way for developers to create and deploy applications, we obviously didn't start with the compute resources. They came later. Like I said, we announced AWS Lambda back in 2014. But we already had some other services that had very similar characteristics. And many people, when thinking about serverless architectures, they only really think about AWS Lambda as a mechanism for replacing the custom code components of applications that they might want to build and might want to run. But actually, the toolbox is a lot broader than that. And we see customers building applications today that are using a very broad cross-section of different service types, some of them AWS services and some of them, as I said before, third-party services. They all share some common characteristics, whether it's object storage with S3, whether it's access to computing resources with Lambda, or whether it's the other data store type, the non-relational high-performance database data store type, DynamoDB. All of these services have the same attributes. They're all very simple for developers to use. They all take away the need to think about scalability in any sense. You just consume the amount of resources that you need, and we'll deliver the capacity to support that rate of consumption. Got this micropayments model with very, very small incremental charges for usage of resources, and we'll talk about some real-world examples of what that can mean for cost to operate different application types later on. Again, in a similar way to capacity planning, you remove the need to do reliability management. If your infrastructure that underpins one of your functions fails, just start it again and it will come up on different capacities. There is absolutely no need for developers to operate a plan for infrastructure reliability. And increasingly, we're working with service components here that have very low latency characteristics. And again, we'll demo that to you a little bit later on as well. So that was the triangle of services that we had, S3, DynamoDB, and then we added Lambda to that a couple of years ago. And what this offers is a mechanism for you to pre-position custom artifacts, custom code, inside AWS, and then have the environment to allow you to execute those custom artifacts created for you on demand. So you'll have a release cycle where you deploy a function, your code snippet into AWS as an artifact. We then wait for qualifying events that will trigger that, and when we receive one of those events, we create the whole execution environment for you, run the code, and then tear it down at the end. And we have this very, very granular metering model that we use to manage the amount of service resources that are available to you, and charge you for those. Okay, so that's really how the model works. I want to get away from theory really and start talking about examples of customers that are using this delivery model today. So the first pattern that we've seen is adoption of AWS Lambda and these other components to create web applications that do not have back-end infrastructure, or at least do not have back-end infrastructure which exists permanently. And the common pattern for doing this is to use the API gateway that we provide. So your web app will be written in a front-end framework like React or an alternative front-end framework, JavaScript running in the browser. And that will communicate with RESTful API or resources that are represented via a RESTful API, and each one of those resources is mapped back into a Lambda function. In fact, each action on each resource is mapped back into a Lambda function. And that's how you express the functionality that's required in the app. And there is literally nothing to deploy other than configuring the gateway and locating the code that you want to run within our service. We then instantiate as many copies of the code, as many containers actually, as are required to run whatever volume of traffic that you have at a particular point in time. We've seen really broad adoption of this. A couple of good examples that I just want to call out off this slide. Periscope, you'll know, it's a peer-to-peer streaming service that's part of Twitter. So you can pick up your phone, you can live stream video, and then viewers can connect to that in real time or view archived recordings for 24 hours. There's a couple of challenges with this. First of all, any streaming service will get use of the type that the streaming provider probably doesn't want. So material that might have its rights held by other third parties, so copyrighted material, but also material that could be illegal or might breach the terms of service. And Periscope use AWS Lambda for evaluating sample frames in video streams to determine whether or not a real-time video stream contains content that fits into either of those two categories. So they'll have skin detection, they'll have image detection algorithms. They run over selected frames, and they're looking for sports content, they're looking for copyright content, and they're looking for content that might breach their terms of service or be illegal. And they do that in real time, and they do it on elastic infrastructure. So when a lot of people are streaming, they've got a lot of functions running concurrently. When nobody's streaming, they have no functions running and they have no costs. Okay, so it's a very elastic model. Another really good example here would be Localytics. They provide an application usage analysis and monitoring service for mobile apps, so you can embed their SDK within your Android application. It'll report back to you on usage metrics, so what's your daily or monthly average usage level, how many users complete particular journeys that you might want to specify in your apps. Maybe you're doing A/B testing with a couple of different versions of an application, and you want to analyze which one of those applications best helps your users meet their goals. Now, it's a service which is quite similar in some ways to something that we have ourselves with our own mobile analytics service. The difference, I think, here is the scale at which Localytics is deployed. They have their agent on 2.7 billion Android endpoints today. So it's absolutely massive in terms of its deployment. And there's about 30,000 different applications that they're providing, or 30,000 different application providers that they're providing application analytics for. The whole thing is built back on AWS Lambda and can help them respond to events both for post-event analytics as well as for real-time triggers. So it's a very large service which is built on AWS. Then we have a lifestyle content provider called Bustle based in New York, where you've got a more comprehensive case study on these guys, which I've included on the slide here. So I'll put these slides on my slideshow after this talk. If you're interested in learning a little bit more about the way in which organizations combine this serverless architectural pattern together with stateful data stores, Bustle's got a really good example of that, where they're doing, again, real-time analytics and long-term analytics using Lambda to deal with events that are emitted by various components of their application. Again, it's well worth taking a look at if you're building web apps and you want to consider using Lambda as a backend for those. Something I want to talk about in a little bit more detail. Everyone's heard of David Guetta, right? Yeah? French DJ? Say house music producer, maybe. In Europe, as you probably know, soccer's a big deal. So, we like to what we call it football, but soccer for you guys. And David Guetta was involved with UEFA. This is the governing body for soccer in Europe. So we have, like you have the Copa de Americas, we have the European Championships, the Euro as we call them. And this year, it took place in the summer, and there was a program, a plan really, to try and get a broader range of fans engaged with the championships. So as part of this, they wanted to build a fan engagement program which would build interest in the championships and might help raise awareness of the championships amongst alternative demographics, and also help raise awareness of the championships outside of the European territory. Okay? And the way they did this was they partnered with David Guetta, and he came up with a concept, actually, creating an audio track, a song, that would have 1 million football fans singing on it. So they wanted to composite together the voices of 1 million soccer fans and use these for producing an audio track. It was called This One's For You. Okay, it was released in July this year. It was pretty successful. He hit his goal of getting his 1 million voices over the course of a 3-month period. Now, the app that was used here was built by a digital agency in the UK called Parallax. I know these guys pretty well. They run the AWS user group in a city very close to where I live called Leeds, so they're very active in the AWS community. It's a small company with around about 50 people, of which about half are visual designers and the other 25 are in project delivery and software development. It's a pretty small company. They were subcontracted to the main digital agency that have the contract with UEFA for their digital brand development, so running UEFA's websites and helping them project their brand digitally around the world. So they're a subcontractor there. They built an app which looks like this. So it's a single-page in-browser application. When you load the app, you're presented with David Guetta explaining to you that he wants you to contribute towards his new single by recording an audio track. Then in the browser, they run the audio capture. They store the audio content and then use that audio content for 2 things. First of all, compositing it together to create the track, so getting all the 1 million voices and having those available for processing with some other audio software that creates the chant, where it sounds like 1 million people in a football stadium, soccer stadium, singing a song. But also there's a viral component to this campaign, so they wanted the users to share artwork and also to share the audio with their friends on social media to help drive awareness of the campaign. This was delivered in Europe, but it was also delivered in several territories in Southeast Asia, Thailand, Korea, Japan, and I think also in China. So it's a global campaign. There are quite a few challenges with this over this very short period of time. This is what they built. So they built a single-page app, in-browser app, with this transaction flow. So when you first loaded the app, thisonesforyou.com, you get a placeholder set of assets that represent the visual style of the app and start playing that video in the background. There's then a transaction to establish what language you speak. So they do a browser-side check to establish what your localization settings are. That hits the AWS API gateway. There's a Lambda function that evaluates the browser localization string, and that issues a redirect, which forces your browser to get language-appropriate content. It's actually transparent because it happens while the video is playing at the top of the app that I showed you, so you don't see this as a user. By the time you've scrolled down, you've already got Korean or Japanese or whatever it is loaded in the browser, so it's completely seamless. You're then asked to provide some details. There's another API gateway transaction, another Lambda function here that writes the details that you provide into a table inside DynamoDB. Now, there's an alternative way to implement that, actually. You could implement that using direct access to DynamoDB from within the browser with another service that we've got called Cognito for temporary API credentials management. But the guys at Parallax chose to build this in a way where each transaction would have a consistent interface. It simplified their development work in the browser side and helped them standardize what they had to build there. So you enter these details, they're stored. You can then optionally link the session to Facebook. This uses Facebook's SDK, which is embedded within the app. So then they've got your social identity. Once they've done that, they then stream the video of David Guetta explaining the recording process to you and allow you to rehearse, actually, so you can sing a couple of times into the microphone. I actually tried to get a room full of developers to do this while this app was live. It didn't work out very well. What I learned is that software engineers and developers do not like to sing in public. So I'm not going to even try and get you to do that. It just doesn't work. So you do the recording. The MP3 file is created within the browser using a browser-side component. A temporary token for upload to S3 is generated through another Lambda function. You get that token back, and then the browser pushes the audio asset directly into a write-only bucket inside S3. So you've written the content, and they have what they want, which is the audio for compositing. And then we get onto the viral component. So there's a few more transactions here to allow the user to submit their details. We generate this picture that you can see at the bottom right of this slide. What they'll do there is grab your image from Facebook, like your profile pic, And then they use an image generation package inside a Lambda function to composite some text layers on top of that and build this piece of album artwork, which is unique to you if you've connected your Facebook account. If you don't, you get this lovely picture of David Guetta that I've got on this sample flow through here. And then you get an opportunity to share that on social. And that's the end of the flow. Okay? Now, what's unique about the application is the fact that it ran for this 3-month period, and it was going to be globally delivered. So it was very difficult for Parallax and for UEFA, actually, to predict how much capacity they would need to support delivery of this app for this very short period of time. And of course, it's just not a fit for traditional infrastructure models where you'd have to buy those assets and have them sitting around for the next maybe 32 months of their lifetime after you've run the app for this 3-month period. So it's a really good fit for the cloud. I mean, that's pretty obvious. So cost comparison. So to build out this N-tier model that you can see top left here with the level of capacity that was required to meet the expected throughput and also with the availability characteristics that they wanted, they calculated that would cost them about $12,000 a month. Okay? So you're talking about $36,000 over a 3-month period, and that was for multi-availability zone with all of the components in it that were required to support their expected peak throughput. Instead, they built it out, as you can see here on the bottom right, using this serverless approach, a collection of AWS service endpoints, API Gateway, Lambda, S3, Dynamo, and SES, which is our transactional outbound email service. So that's how they provide a follow-up email with your social image in it. And this was built entirely using this serverless pattern. This one, does anyone have a guess what the costs were for the bottom right option? You're close. You're very close at the back there. I'll give you that. So the first dollar of operating costs was $9. First month of operating was $9.30. Okay, this is as they started to ramp up. Okay, and then they started to get really busy, and they hit $179 in the 3rd month. But most of the spend was in storage in S3 for all of the assets that they accumulated. The actual compute costs were nearly zero because with Lambda, you get 1 million function invocations and 400,000 gigabyte seconds in the free tier every month forever. So if you don't break through that threshold, you won't get a bill for the service. You've got to have quite significant usage to actually start spending. So it just disconnects the cost structure from usage in many ways. And as I said before, you don't have anything to plan. So it wouldn't have mattered if they'd had 10 times the volume. They would have had the capacity there. They would have just had a slightly larger bill for the amount of storage that they were consuming. But there's no overhead. It's a no ops-based approach for them. It's a pretty cool case study in my view. And I'll show you some resources at the end where you can learn a bit more about that. So that's in web applications. And a couple of other things that we see a lot of usage for. One of them is in trigger-based data processing. So I've got a stream of data that's arriving with me either in real time or periodically, and I want to respond to that. I might want to update counters. I might want to trigger thresholds. I might want to consolidate, calculate things like moving averages or sliding windows. You can do all of this with Lambda by triggering functions that work upon data as it flows through a data stream, maybe Amazon Kinesis, or even as data is deposited in larger chunks as S3 objects. So those are supported triggers for Lambda, and you'll get metadata, as I'll show you later, about the event that's triggered the function, and you can operate on those metadata fields and, for example, access S3 objects and process them or read records out of Kinesis and perform computational actions on them. This particular example is a security provider called FireEye that provides intrusion detection alerting. And they use Lambda here in a way which is quite similar to Hadoop. So they're splitting their data stream across a number of different processing engines. It just happens to be that the processing engines are created ephemerally. They're just created each time a packet of data arrives. They'll evaluate that. And if they've got qualifying events, maybe they want to raise an alarm, maybe they've counted a certain number of an event type, they'll trigger some action with that, present that in a web interface, and customers or their operations center can take action on it. But the system just scales elastically in accordance with whatever the current volume of data is. And obviously with security events and attacks, that can vary wildly depending on what's happening in the world, right? So again, it's a really good fit for that use case. Third category of usage is IoT, and this opens up actually a whole area that we could spend another hour talking about, to be honest. The first thing is the Amazon Echo, which a lot of you will know here, has been available in the US for quite a long time now. This voice-activated speaker that we have. I don't know if anyone's investigated development with something we have called the Alexa Skills Kit, which is a programming framework for people that want to build voice-enabled applications, but the whole of the Alexa Skills Kit is enabled and powered by AWS Lambda. When you speak to your speaker, we do a speech-to-text conversion. We create a JSON object that represents what you've said, and we give that JSON object to a target skill. So you can do things like, say, Alexa, tell Sonos to play EDM. And if you've got the Sonos skill connected to your own personal Alexa account, that will invoke a Lambda function that will in turn talk to your Sonos speaker and activate whatever it is you've asked it to play. But the functionality in evaluating what you've said and triggering actions, that's all delivered using AWS Lambda. And any developer can write a skill, by the way. Capital One have written a skill that enables you to use voice to interrogate your credit card balance. It's a Lambda function that has credentials to talk to your specific account API endpoint and retrieve your data, and then speak that back to you through the speaker. So it's an extensible framework for people that want to build voice apps. So that's one example of IoT. Another example would be this. This is our IoT Service Platform. And this really does take the idea of serverless a little bit further. So Lambda is just one of the targets that you can see top right here, but there's an MQTT gateway for receiving IoT messages with high efficiency and low power consumption. There's authentication and authorization with mutual TLS encryption and certificates. And then there's a device SDK. And then we have this rules engine. Now, the rules engine can look inside messages that you're sending from connected devices, and it can route those to different endpoints. So you can have one device emitting messages, and a message class or messages that meet or match or exceed certain thresholds or attributes can be routed to specific Lambda functions. You can have a whole array of functions at the back end that perform different actions based on message routing. And I'll show you that in the console before we wrap up. So that's a very, very common use case as well. But you can do a lot with IoT applications using this platform without actually having to use Lambda. There's a lot of intelligence in the rules gateway itself, the rules engine itself. And then lastly, I think probably interesting for this audience is this idea of extending or augmenting AWS to add features and functionality that we don't have yet, but you might think is valuable. And we've got customers using integration events that are emitted by other AWS services to extend the automation capabilities of the AWS cloud. So some good examples here. Back on Capital One again, they've released an open source project called Cloud Custodian, which is all about compliance monitoring, in their case for financial services. They use events that are emitted by CloudWatch events, and they evaluate state changes within there, and you can use it within your AWS account, and they can check whether or not you've done something which will take your security posture outside of a compliance guide rail that you specify. So it might be adding a security group to an instance which is too permissive. You know, we can detect that async with something like Trusted Advisor, but with this software that they've created, you could automatically remediate that. You could automatically apply a more restrictive security group to that instance, or even terminate an instance if it didn't meet certain compliance guidelines that you'd specified. That's using CloudWatch events. With lifecycle hooks, you can act upon things like auto-scaling events. So I might have brought up a new instance which has got a certain set of services on it. I could use an event from that action to trigger a Lambda function which registered those services in DNS and made them available for usage. So that would be integrating lifecycle hooks via a Lambda function. Config rules is a little bit like Cloud Custodian, but it's our own service for compliance monitoring. It provides very similar functionality. You can create config rules in JavaScript or Python or Java. You can evaluate changes to your AWS resources, and you can act upon those state changes. Or we can support scheduled jobs. So this is triggering Lambda functions with certain intervals down to a 1 minute granularity now. So think of it a little bit like cron, but without having to have an EC2 instance hanging around the whole time just waiting for its clock to change. You just trigger those events when you need them, and you express the actions that you might normally have in your cron tab within a set of Lambda functions. So it also becomes much easier to control the life cycle of those events, so you can apply source control tracking and deploy new scheduled events in a way which is managed by your deployment tools rather than being a little bit harder to manage just sitting on an EC2 instance encapsulated in that way. And then we've got ecosystem tools as well. And remember that Lambda functions have IAM roles. Now, one of the main restrictions at the moment with Lambda is the function duration. So you can't run a function for more than a maximum of 5 minutes. After 300 seconds, the functions will get terminated. And that's really a backstop to prevent customers from having functions that don't terminate cleanly, and therefore running up large bills. We'll reap them down, clean them down after that period of time. But if you do have a longer running job that you need to execute, well, you can use a function with an IAM role to start a container on ECS, or to start an EC2 instance with a certain army and profile on it. So you can build longer-term actions that are also themselves event-driven by combining Lambda together with other more persistent AWS services, using the IAM Roles permissions model to do that. So that's actually a very common pattern for customers that have got sophisticated applications that are event-driven to use that kind of model. Okay. And then lastly, out on the ecosystem, we've seen so much stuff here that's been so creative from customers that have built really, really good things. One of the things we did actually was we released these IoT buttons this year, which you might have seen. I'm going to talk about one of those in a second. I got them with me. But when we gave them to developers, they were all using Lambda to basically build the wildest, most creative things they could build. This one blog I saw, a guy had written, what should I do for dinner? And he presses the button, and it evaluates factors like, from his home, so what's the weather? How much money do I have in my bank account? How long will it take me to get an Uber? What's the current rating of restaurants close to me on OpenTable? And then it sends an SMS to his phone using Twilio saying you should go here. You've just been paid, so we'll take you somewhere nice. The weather's sunny, you can walk it in 5 minutes. And that's his logic. And it's all expressed back in JavaScript using AWS Lambda, but it's triggered by one of these guys, by a AWS IoT button. So you can decouple your application functionality from the triggers. So the life cycle of the app becomes independent of the event. It's pretty cool. And actually, that's what I'm going to show you now by way of a quick demo. So let's see if I can get everything working. So I didn't mention, obviously you can deploy and control all of these resources using Terraform as well. So you can have all of the components of your serverless application expressed as a set of Terraform configs. And then you can create DynamoDB tables, Lambda functions, event triggers, Kinesis streams, S3 buckets, everything together as one coherent entity. And this is one of the challenges, actually, that Adrian talked about in his talk. With this new model, it's harder to attack because it doesn't exist, but it can also be harder to link together the resources that are required to run the app. And having a meta configuration manager which sits above that, whether it's Terraform or our own CloudFormation, is actually a really useful thing to have. It allows you to encapsulate all the entities associated with your app and obviously control their life cycle and deploy them as one coherent unit. So it's a really, really powerful tool. This is the Lambda Console that you can see here. And I'm going to need an event to trigger my function, and my event trigger is going to come from this IoT button. So this just sends a pre-formatted block of JSON to our IoT service, and I have a rule there which will route that preformed block of JSON to a specific Lambda function that I've already created. So if I press that twice in sequence, you should see there's a white light on there, which is flashing. I hope you can see that. And all being well, that should turn green, and then something will happen, which I will show you. So I've sent my message. And that's going to trigger a Lambda function that I've got pre-deployed. And the code in the function looks like this. So I'll just enlarge this a little bit. I'll apologize to any people that hate Python now, because it's written in Python. So this is the code that's in my function. You can see it's small, self-contained, okay? And it has an event handler in it. And when uploading your function, you specify the entry point. So what is the event handler that I'm going to use for this particular Lambda function? You can see that I'm dumping some JSON there, which is the event payload that I've received off my device. And I then do something very simple, which is just construct a string called status to post. And I use the Twitter API with some credentials that I've already injected into my environment through this external module to construct a tweet and send that using AWS Lambda. And if I look on my Twitter account, I've got quite a few Twitter accounts, but I've got one called, I was told I should have an isolated test account, so I created an account called isolated test. If this works, you will see it in a minute. Okay, so you can see I've got some text there, and you should also be able to see the timestamp on that. It's a minute old, so that was generated by the action that I took. So my function's been invoked as it's received that message, and that's resulted in a piece of content hitting the Twitter API and then getting posted. So let's just say that I wanted to modify that and change what happens there. I want to move this function actually from test into production. So I've got another set of credentials which contain my actual real account, not this test account that I've been using. So I'm going to update my code here to reflect that. I'll load this different module which has a different set of creds in it. And then let's put something in here which makes it distinctive where we are. So we use the event hashtag. Okay, and we'll save that out. I've got a small, tiny little script here. Oh, what did I do? After the what, sorry? Space. There. No. There. Yeah, actually there's padding in the timestamp, so it'll probably work. But yeah, good spot. So, and then I've got a tiny little build script here which just repacks my deployment artifact. So when you're deploying to Lambda, you can either write code directly in the console or you can deploy zip files which contain all the build artifacts. Because I've got modules, a zip file is the only way that I can actually deploy this. I've got more than one source file. And then I have a Terraform down here. So if I Terraform plan, and the Terraform config is here. So you can see I'm defining my provider, obviously, the resources that I need, an IAM role for the function itself, which enables it to log. And then what you can see at the very bottom here are the resources associated with the function. So the test payload. And it uses this cool thing, actually. It calculates a SHA-256 on your deployment artifact. And only if the SHA-256 on the deployment artifact has changed since the last deployment will it actually push the function, which is actually pretty cool. If you've got an app that's got multiple functions in it, you don't want to be refreshing them all every time you change one. And using this model, it allows the state engine to just deploy the stuff that it needs to deploy. So this should be deployed. I once tried to do this demo in South Africa. I can say the Wi-Fi there was even worse than this, but only just. One thing that we can show you while that happens, something that I get asked about quite a lot is there's quite a lot of different event sources. So how do you know what payload you're going to get from different event types? You can actually see that here in the console. So if you hit function test, you'll see that you get a drop-down, and the drop-down includes all of the supported event sources that have specific schemas associated with them. So if I wanted to operate on the creation of objects in S3, for example, this is the event schema that I'm going to receive each time I create an object. And I can write my function then to handle that event schema, potentially grabbing the object and processing it. And there are similar event schemas for all of the different event types. You can probably see that IoT and the API gateway are not present in the list. And the reason for that is, with those event types, you just get whatever the payload is. Whatever's in the MQTT message will be provided as event context, or whatever's inside the request body from the API gateway be given directly to the function as the event context. So you can then process your own custom schemas with the API gateway or with IoT service, because the schema is defined by whatever you post, essentially. Here we are. So we've got our plan. Want to change, we'll deploy that. Hopefully this will be faster. Probably not, but hopefully. Okay, while that happens, I'm just going to jump back onto my slides and just show you a few resources that you can use if you want to learn a little bit more about what I've talked about today. It's taking a little bit of time to do the deployment. So we've obviously got a lot of documentation about Lambda on the AWS website. It's awsamazon.com/lambda. Okay, so that's what you can see top left here. And when I circulate these will be clickable links. The top right is an hour-long session which is presented by the GM for AWS Lambda and API Gateway, a guy called Tim Wagner. And that's really got a lot more detail on how you would tackle certain use case requirements using Lambda. So service restrictions and limits, how you can combine API Gateway and Lambda together, and also situations where you shouldn't use Lambda, as well as some information about VPC integration. So you can now start Lambda functions that are inside VPCs. What happens in practice is ENIs get attached to the host that has the Lambda function running on it. They're wired into the function. Then you can access relational databases or other resources that might be inside a VPC from inside running Lambda functions. That's quite a new addition, quite important. And then at the bottom, an interview about some of the detail on this campaign that was built for the David Guetta app. And this is really interesting, actually. It includes a lot of information about lifecycle management for functions, testing harnesses, and source code control techniques that the guys at Parallax developed. This was the first thing they'd ever built in this way. And they share quite a lot of their learnings about how they built a framework around the deployment tools to really make it possible for them to manage the deployments coherently. That's pretty cool. And then much newer from them is a guide on getting started with scheduling. So how can you replace instances that you might use for scheduled tasks and instead use Lambda functions with scheduling and take out some of the fixed costs of running EC2 instances for scheduling. So I'll make all of these available as clickable links when I circulate the deck from this talk.